Whole house surge protectors from WireMold and Intermatic are designed to protect the entire house from incoming voltage spikes. They are installed on the main electrical panel and provide protection to all connected devices. These units offer good surge protection and are suitable for most residential applications. Larger surge protection systems with plug-in modules provide additional protection for specific circuits or sensitive equipment. Plug-in modules can be added to protect high-value electronics such as computers, home theater systems, and medical devices. These systems typically offer higher surge protection capabilities and customization options. The effectiveness of surge protectors decreases as the length of the leads increases. For optimal protection, the leads between the surge protector and the breaker should be as short as possible. In this case, a 12 to 20-inch lead length should not significantly reduce the effectiveness of the surge protector. Outlets with built-in surge protection provide additional protection to connected devices. They can be used in conjunction with whole house surge protectors to enhance overall protection. However, outlets with built-in surge protection may not offer as high surge protection capabilities as dedicated surge protectors. Surge protectors require a proper ground connection to work effectively. Ensure that the electrical panel is properly grounded. Choose a surge protector with a surge protection rating that meets or exceeds the electrical requirements of the equipment being protected. Consider the warranty and customer support offered by the manufacturer of the surge protector. A combination approach is recommended. Firstly, install a whole house surge protector from WireMold or Intermatic to provide basic protection. Secondly, supplement this with plug-in modules from a larger surge protection system to protect specific high-value electronics. Thirdly, consider installing outlets with built-in surge protection for additional protection at the device level. Ensure that computers will be placed on uninterruptible power supplies to provide battery backup in the event of a power outage. This comprehensive approach will provide optimal surge protection for all electronics. When selecting surge protection devices, several key factors should be considered to ensure the chosen solution effectively safeguards electronics from voltage spikes. Firstly, it's essential to understand the different types of surge protection available, including whole house surge protectors, plug-in surge protectors, and surge protective outlets, each offering varying levels of protection and coverage. Secondly, determine the surge protection needs based on the sensitivity and value of the electronics being protected, as more critical or expensive equipment may warrant higher levels of protection. Thirdly, evaluate the surge protector's specifications, such as its surge current capacity measured in kiloamps, its voltage protection rating, and its energy absorption capability measured in joules, ensuring these ratings meet or exceed the requirements of the protected equipment. Fourthly, consider the installation location and ease of installation, as whole house surge protectors require professional installation at the main electrical panel, while plug-in surge protectors and surge protective outlets can be easily installed by the user. Fifthly, check for compliance with industry standards, such as Underwriters Laboratories 1449, which sets safety and performance requirements for surge protective devices. Sixthly, assess the surge protector's warranty and insurance coverage, as reputable manufacturers typically offer warranties and insurance policies that cover damage to connected equipment caused by surge events. Seventhly, think about the surge protector's diagnostic indicators such as LED lights or audible alarms, which provide real-time status monitoring and alert users to potential problems or failures. Eighthly, factor in the surge protector's cost-effectiveness, considering the balance between its price, performance, and longevity, ensuring it offers the best value for the investment. Ninthly, research the manufacturer's reputation and customer reviews, as established brands with positive feedback are more likely to provide reliable and effective surge protection solutions. Tenthly, remember to periodically inspect and test the surge protector to ensure it's functioning properly, replacing it as needed to maintain optimal protection. Implementing a layered approach to surge protection can offer the most comprehensive defense against power surges. Firstly, install a whole house surge protector at the main electrical panel to protect the entire home from external surges originating from the power grid. Secondly, use plug-in surge protectors at individual outlets to provide localized protection for sensitive electronics connected to those outlets. Thirdly, utilize surge protective outlets in place of standard outlets to offer an additional layer of protection at the point of use. Fourthly, employ uninterruptible power supplies with surge protection capabilities for critical devices like computers and servers to safeguard against both surges and power outages. Fifthly, ensure proper grounding of the electrical system to provide a safe path for surge currents to dissipate. Sixthly, regularly inspect and maintain all surge protection devices to ensure they are functioning correctly. Seventhly, monitor weather forecasts and be prepared to disconnect sensitive electronics during thunderstorms or other events that may increase the risk of power surges. Eighthly, consider using surge filters for specific devices like phone lines and cable connections, as these lines can also carry surges. Ninthly, keep a record of all surge protection devices installed, including their specifications, warranty information, and replacement dates. Tenthly, educate family members or employees about the importance of surge protection and how to identify potential problems. The selection of a surge protector requires careful consideration of various factors to ensure it meets specific needs and provides adequate protection for valuable electronics. Firstly, determine the type of surge protector needed, whether it's a whole-house surge protector for comprehensive protection, a plug-in surge protector for individual devices, or a power strip with surge protection for multiple devices. Secondly, assess the surge current capacity of the surge protector, measured in kiloamps, which indicates its ability to withstand high energy surges. A higher surge current capacity is generally better for areas with frequent or severe power surges. Thirdly, evaluate the voltage protection rating of the surge protector, which specifies the maximum voltage that will be allowed to pass through to the connected devices. A lower voltage protection rating indicates better protection. Fourthly, check the energy absorption rating of the surge protector, measured in joules, which represents the amount of energy it can absorb before failing. A higher energy absorption rating provides longer-lasting protection. Fifthly, consider the number of outlets and the spacing between them, ensuring there are enough outlets to accommodate all the devices that need protection and that the spacing is adequate for larger power adapters. Sixthly, look for certification from reputable testing organizations like Underwriters Laboratories, which ensures the surge protector meets safety and performance standards. Seventhly, check the warranty offered by the manufacturer, as a longer warranty period indicates greater confidence in the product's reliability. Eighthly, read customer reviews to get insights into the real-world performance and durability of the surge protector. Ninthly, consider additional features like indicator lights that show whether the surge protector is functioning properly and automatic shut-off mechanisms that disconnect power in the event of a surge. Tenthly, compare prices from different retailers to find the best deal, but prioritize quality and performance over cost. When installing a whole house surge protector, several steps should be followed to ensure proper installation and optimal protection. Firstly, hire a qualified electrician to perform the installation, as working with electrical panels can be dangerous and requires specialized knowledge and skills. Secondly, turn off the main power breaker before starting any work to prevent electric shock. Thirdly, select a suitable location for the surge protector near the main electrical panel, ensuring it is easily accessible for inspection and maintenance. Fourthly, connect the surge protector to a dedicated circuit breaker in the electrical panel following the manufacturer's instructions and local electrical codes. Fifthly, ensure that the surge protector is properly grounded to provide a safe path for surge currents to dissipate. Sixthly, label the circuit breaker for the surge protector to make it easy to identify in the future. Seventhly, test the surge protector after installation to verify that it is functioning correctly. Eighthly, inspect the surge protector regularly for any signs of damage or wear and replace it if necessary. Ninthly, keep a record of the installation date and warranty information for the surge protector. Tenthly, educate the occupants of the home about the purpose and function of the surge protector and advise them to report any power surge events or unusual electrical behavior. The effectiveness of surge protection can be influenced by various factors, and understanding these factors is crucial for ensuring optimal performance. Firstly, the quality of the surge protection device itself is paramount, with higher quality devices offering better protection against a wider range of surge events. Secondly, the surge current capacity of the device, measured in kiloamps, determines its ability to handle high-energy surges without failing. Thirdly, the voltage protection rating of the device specifies the maximum voltage that will be allowed to pass through to the protected equipment, with low ratings indicating better protection. Fourthly, the grounding of the electrical system plays a critical role, as a properly grounded system provides a safe path for surge currents to dissipate. Fifthly, the proximity of the surge protection device to the protected equipment is important, as devices located closer to the equipment offer better protection. Sixthly, the length and quality of the wiring between the surge protection device and the protected equipment can affect performance, with shorter, higher quality wiring minimizing impedance and voltage drop. Seventhly, the presence of other electrical devices on the same circuit can impact surge protection effectiveness, as these devices may generate their own surges or draw current during a surge event. Eighthly, the type of surge event, whether it's a lightning strike, a utility switching surge, or an internal surge, can influence the level of protection required. Ninthly, the age and condition of the surge protection device can affect its performance, as devices degrade over time and may need to be replaced periodically. Tenthly, regular inspection and testing of the surge protection device are essential to ensure it is functioning properly and providing adequate protection. Selecting the appropriate surge protection for specific electronic devices requires careful consideration of their individual needs and vulnerabilities. Firstly, identify the types of electronic devices that need protection, such as computers, televisions, appliances, and home theater equipment. Secondly, determine the power requirements of each device, including its voltage, amperage, and wattage, to ensure the surge protector can handle the load. Thirdly, assess the sensitivity of each device to voltage fluctuations and power surges, as more sensitive devices may require higher levels of protection. Fourthly, consider the location of each device and the potential sources of surges such as lightning strikes, utility switching, or internal electrical events. Fifthly, choose surge protectors with appropriate surge current capacity, voltage protection rating, and energy absorption rating for each device. Sixthly, use plug-in surge protectors for individual devices that are easily accessible and have standard power cords. Seventhly, use power strips with surge protection for multiple devices that are located in the same area. Eighthly, use uninterruptible power supplies with surge protection for critical devices like computers and servers that require continuous power. Ninthly, use surge filters for phone lines, cable connections, and network connections to protect devices connected to these lines. Tenthly, consult with a qualified electrician to determine the best surge protection solutions for complex or high-value electronic systems. Maintaining surge protection devices is essential for ensuring their continued effectiveness and longevity. Firstly, inspect surge protectors regularly for any signs of damage, such as cracks, burns, or loose connections. Secondly, test surge protectors periodically using a surge protector tester to verify that they are functioning correctly. Thirdly, replace surge protectors after they have experienced a significant surge event, even if they appear to be working, as their internal components may have been damaged. Fourthly, replace surge protectors every 2 to 5 years, depending on the manufacturer's recommendations and the frequency of surge events in the area. Fifthly, keep surge protectors clean and free from dust and debris, as accumulated dirt can reduce their performance. Sixthly, avoid overloading surge protectors by connecting too many devices to them, as this can cause them to overheat and fail. Seventhly, use surge protectors only for their intended purpose, and do not use them as extension cords or adapters. Eighthly, store surge protectors in a cool, dry place when they are not in use. Ninthly, keep a record of the purchase date, warranty information, and replacement date for each surge protector. Tenthly, educate family members or employees about the importance of surge protector maintenance and how to identify potential problems. The role of grounding in surge protection is critical for ensuring the safe and effective dissipation of surge currents. Firstly, grounding provides a low impedance path for surge currents to flow back to the source, preventing them from damaging sensitive electronic equipment. Secondly, a properly grounded electrical system helps to equalize voltage potentials, reducing the risk of electrical shock and fire hazards. Thirdly, grounding is required by electrical codes and standards to ensure the safety of electrical installations. Fourthly, the grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, that is connected to the electrical panel with a grounding conductor. Fifthly, all electrical outlets and equipment must be properly grounded to provide a continuous path for surge currents to flow. Sixthly, surge protectors rely on a properly grounded electrical system to function effectively, as they divert surge currents to ground. Seventhly, the quality of the grounding system can affect the performance of surge protection devices, with lower impedance grounding systems providing better surge protection. Eighthly, regular inspection and testing of the grounding system are essential to ensure its continued effectiveness. Ninthly, any damage or corrosion to the grounding system should be repaired promptly to maintain its integrity. Tenthly, consult with a qualified electrician to ensure that the electrical system is properly grounded and that the grounding system meets all applicable codes and standards. Understanding the different types of power surges is essential for selecting and implementing appropriate surge protection measures. Firstly, lightning strikes are the most powerful and destructive type of power surge, capable of delivering thousands of amps of current to an electrical system. Secondly, utility switching surges occur when the power company switches equipment on or off, causing voltage fluctuations and transient surges. Thirdly, internal surges are generated by electrical devices within the home or building, such as motors, appliances, and electronic equipment. Fourthly, inductive load switching surges occur when inductive loads like motors and transformers are switched on or off, creating voltage spikes. Fifthly, electrostatic discharge surges occur when static electricity is discharged into electrical equipment, causing damage to sensitive components. Sixthly, transient voltage surges are short-duration voltage spikes that can be caused by a variety of factors, including lightning, utility switching, and internal electrical events. Seventhly, sustained overvoltage surges occur when the voltage remains above the normal level for an extended period of time, potentially damaging electrical equipment. Eighthly, undervoltage surges occur when the voltage drops below the normal level, which can also damage electrical equipment. Ninthly, frequency variations can also cause surges and damage to electrical equipment, especially sensitive electronic devices. Tenthly, harmonic distortion can create voltage and current surges that can overheat and damage electrical equipment. Comparing whole-house surge protectors and plug-in surge protectors helps to understand their respective advantages and disadvantages. Whole-house surge protectors are installed at the main electrical panel and provide comprehensive protection for all electrical circuits and devices in the home. They are effective at stopping surges that originate from outside the home, such as lightning strikes and utility switching surges. However, they may not provide adequate protection against internal surges generated by devices within the home. Plug-in surge protectors are installed at individual outlets and provide localized protection for devices connected to those outlets. They are effective at stopping internal surges and can provide additional protection against external surges that make it past the whole-house surge protector. However, they only protect devices connected to them and do not provide comprehensive protection for the entire home. Whole-house surge protectors require professional installation and may be more expensive than plug-in surge protectors. Plug-in surge protectors are easy to install and relatively inexpensive. Whole-house surge protectors protect all electrical devices in the home, including those that are not connected to surge protectors. Plug-in surge protectors only protect devices that are connected to them. Whole-house surge protectors can help to extend the life of electrical devices by reducing the stress caused by voltage surges. Plug-in surge protectors can help to prevent data loss and equipment damage caused by power surges. Ultimately, the best approach to surge protection is to use a combination of whole house surge protectors and plug-in surge protectors to provide comprehensive protection for all electrical devices in the home.